Hi, my name is Mehmet Emre Andıran. I am in Physics 102 Section 3. I'm going to talk about my Physics 102 lab project. My project is titled as the magnetic field around the current carrying wire. Due to electromagnetism, a current in a wire produces a magnetic field around the wire. The aim of this experiment is to observe the relationship between the magnetic field and the current flowing through a very long wire and also the distance to the wire. To calculate the magnetic field around the very long wire, the Biot-Savart law can be used. The very long wire can be likened to an infinite wire, so the magnitude of the magnetic field around the wire is given as this expression. In this experiment, I created a DC circuit featuring a power supply, a resistor, and a segment of a very long straight copper wire. Using a Gauss meter, I measured the magnitude of the magnetic field around the wire at 1 cm and 2 cm distances at 5 different currents: 0.2, 0.3, 0.4, 0.5, and 0.6 amperes. I then created this table with my measurement. Using this equation I derived from the Biot-Savart law, I calculated the theoretical magnitudes of magnetic field for every measurement case. I then compared my experimental values to the theoretical ones by calculating their individual percentage errors. I then filled in these two graphs and drew the lines of best fit that pass through the origin as if the current is zero. The magnitude of magnetic field created by the wire is also zero. I compared their slopes with the theoretical slopes found from the Biot-Savart law and calculated their percentage errors. At a distance of 1 cm, 3 of my 5 measurements had 0% error and the other 2 had a maximum of 10% percentage error at 0.5 amps. So the errors were insignificant. Then, when I compared the slope of the line of best fit with the theoretical slope, the percentage error was 0%. So my results were very in line with the theoretical values. Doubling the distance halved the magnitude of magnetic field, which fit with the expression derived from the Biot-Savart law, meaning distance is inversely proportional to the magnitude of the magnetic field. This time, 4 out of 5 measurements perfectly matched with theoretical values, and only at 0.4 amps the percentage error was 25%, so it was an outlier and negligible. The slope of graph 2 also matched with the theoretical value with a percentage error of 0%. Both slopes having a percentage error of 0% meant that even if not all my measurements were near identical to theoretical values, my overall measurements were very consistent with the theoretical values calculated using the expression derived from the Biot-Savart law. A cause of these minor errors might be that the Gauss meter only displayed values up to 10 to the minus 6 Tesla accuracy, and the measurements in this experiment had an order of magnitude of 10 to minus 6 Tesla. Human error might also be present as I was measuring the magnetic field with a handheld Gauss meter and may not have waited for the current to settle as I changed it. All in all, although there were some minor errors, the results found from this experiment significantly match with the theory, so the experiment was successful.